Right. Welcome back to another episode of me losing at Prime Mover. We'll call this day 6, I guess. And so this first, see everything. So this first level we're working on is copy if. And I have looked at this a little bit, I think on my last video. Towards the end, I took a look. So this one actually looks easier than the last one we did. The last one was the last one was the reverse, and this one, I don't even know. I think this is the solution I ended up going with. Let's run it real quick. Nope. This one was it. This? Did I solve it? What? I most definitely solved it. I guess I broke it. Well, in any case, that video should exist, I believe. If not, I guess I'll go back to that. I'll check it out after this. But yeah, so this one looks significantly easier. So copy if. We need to send C to A, and we need to send D to B. If C is -1, instead we're going to copy D to A. So instead of, I don't like the word copy. I think it's easier to understand if you just say send D to A. If D is -1, instead we're going to copy C to B. And C and D are never 0. So the reason they use copy is because, so if you look, this first input is a -1. So instead of sending 5 only to B, we're also going to copy that input and send it to A and B. So you're going to, copy is another way to say duplicate, right? We're going to send both of those. So first thing we do, let me back up a little bit. So C and D are never 0, so that's important. Also important to note, they're never going to be bigger than -1. I don't know if that's relevant or not, but it not being 0 is very important. No, having no 0 inputs is very important. Yeah, and so it looks pretty simple, right? We can just send C to A, we're gonna send C to B, and we're just gonna implement some kind of locking system, right? By default, I usually just like to leave it out here, just so I have all 4 cardinal directions to work with. So do something like this. We'll lock it. Once I have an input coming through, I'll come back around and unlock it, like so. Obviously, it's going to start unlocked, so the first number gets through. Every subsequent number will lock the lock. So then we can just have it get deleted. So our input's going to come along here. It'll get duplicated, right? So one of the inputs is going to go here, and then the other one will come along this track and unlock the next set of inputs, right? And then all of this will be mirrored. So we'll just start on the left side here. All this is going to be mirrored on the right side. So I can literally just, I can code the whole thing or make the whole system over here, and then use this function to mirror it and post it over here. So like I said, we got this lock system. So the first, we have a way to control the flow of the inputs, right? So that's step 1. And let me actually open up my notepad here, my paint.net. So our first step is to, I don't even need to write it, control the flow, right? Next step, we need to check. Oh, let me change the color to white and then change the size. 10. All right, so we need to check. And again, I tried to use white. I don't know why I don't have the color white. Go. So check for -1. That's the first thing we need to do. So let's just go ahead and hide inside of a chip here. We're going to check for -1. And again, we have no 0 inputs, so we can have the 0 facing the input side here, right? Now, if it is negative, so let me back up. If it's positive, we just want to send it to A. So we can just do something like this, right? So let's say the first number was a 6. 6 would come along here. It would pass through here, no problem, and then lock this. The 6 would then go along this positive track, and then we'll just throw it in here. So the 6 is going to come along, get duplicated. It'll send one to this, right, which is that 6 input here, and then also it will unlock the next set of inputs. So if we have a positive input, we're all good. This works already. Now, if we can test this too. Obviously, the first input isn't positive, but we can pretend it is, and we can even just do this right now. So just to test, make sure the system works. The -1 enters here. Obviously, it'll go through, no problems there. Get duplicated, and boom, next input goes through, right? So that works. This system works already. Now, what we can do is, so we want the positive ones to come through. If we have a negative input, we can just delete it, right? Because we don't need to have the -1 enter this at all. -1 does not need to. Oh, also let me explain why I'm not wearing a shirt. It's really hot and I don't have AC in my house, so yeah. All right, so here's what I'm thinking. If we just delete it, right, because we don't have to literally copy it, right? I don't need to turn this -1 into a 5 or whatever. I can just delete it, and then I can just send this D input to A. So what we'll do is we'll change this track to this. Now, if we have a negative input, we can delete it, and then we can just send. So we'll probably have something like this. So we'll have the D input come in. You know, obviously it won't look like this. We'll have the D input come in through this right side, and we'll put a button here. So normally, if the D input comes through, it would switch this track to the left. We don't want it to switch to the left. So we want it to come to the right, and then always stay on this right path. So we have the button here, and then we can just feed this into A, right? Sorry, my brain is still trying to figure out why the reversal puzzle, what happened there. I guess I broke it. Anyways, so we have the D input come along here. The C input will get deleted. No problems there. Now, if we want to use the C input, we don't want this D input to come through. So we need to, well, I mean, honestly, we could do, I was going to say we could duplicate it, but we don't even need to do that. We can do something like this. And my first instinct was to duplicate it, but honestly, we could just do this. So if the C input is a +6, for example, and assuming this is enough slow wire, the positive input will come through here and trigger this, right? So the D input, instead of getting sent to A, the D input will then get deleted, right? So look at our notes here. Check for -1. We have that. And then, all right, if -1, delete -1, and then send D to A, right? And again, we're not worrying about sending D to B at all because we're just going to mirror this system. So if -1, delete -1, we have that, and then we need to send D to A. We have that. If not -1, if not -1, we need to delete D, and I don't know how to phrase it, but we need to make sure the system doesn't get messed up. So whatever system we have here, this should work. So if D gets, if this button is pressed, D will then get deleted. And we can also, again, we can duplicate D. And so D will go into its own mirrored system. And this is just the second D input that we can delete. We don't need to hang on to it for any reason. So, yeah, this should work, I think. And so we can just test this. With this first input here, we'll do something like this. Lock it. So let's test this first input. So this first one, the -1 should get deleted, and then the D input should come through. So 5 is getting sent to B. Perfect. -1 is entering here. This is locked. That's locked. Oh, sorry, I got scared. I thought the lock was down here, and I was like, why is it going? Okay, that's locked. And the 5 is here. Now, this might get here too fast. So, you know, easy solution there. Am I blind? Oh yeah, the -1 got deleted. And then, oh, I had this set the wrong direction. So the 5 should come through and then hit the button and it gets reset. Perfect. And then 5 should get sent to A and then unlock the next input. Sweet. So I mean, I think we're done. Like I said, that was a lot easier. So I think I can just, again, mirror this system somehow. We'll copy this, the M to mirror here. You can just connect these. All right, so I need, let me back up a step actually before we mirror. So I need to also send the C input to D and then vice versa. So we'll move this down here. Move this down here. Still want this to be deleted. And we'll have the lock here. And then we'll put a duplicator here and put this here. And so now we're going to send C to the D side as well. Just leave this here. So now the C input will get sent to D and then be in the same system here. So we'll go ahead and copy this. Hit the M to mirror. And then we just need to, oh man. Kind of running out of space here. So we'll do this. We'll just move this over one. All right. So we need this. How do I do this? So I want this D input to come over to here. I guess I'll just do something like this. The D input has to come over here. C input has to come over here. And then we'll connect these two. So I don't know. I don't know if this is, well, I mean, we'll test this, so we'll see. The first number is -1 and a 5, so we should get a 5 coming out of both of these. So both the inputs are coming into this system. And then the question is, is the 5 too fast? So 5 and -1 both coming through. And we'll just use the -1, I guess. So looks like the 5 is going to beat the -1 here. It's a tad bit too fast. So honestly, that should work. Boom. Okay. Now the -1 should get deleted. And then 2 5 should be sent. And then also the next sequence should be sent through. These are not in sync, and so I foresee a problem. I foresee a problem. So that they're gonna just slowly get more and more out of sync. So if I could use only one of these, I think it would be better. So, try this. Try this. Oh. I have a brain, I swear. It's in there. I swear it's in there. Okay. And then we'll just add maybe some slow wire here. So we're not using the D input at all. We're just using the C input to unlock the next set of inputs. And that way I should be able to sync them up a little bit better. I don't have to worry about them coming in at the same time. Right. Slow wire and boom. That was actually perfect. Okay. Sweet. Now they're getting deleted. We got a 6 and a 4, so 6 and 4 should both get through, no problems. These 6 and these 4 should get deleted. We'll watch the time on that. Go for another step. Perfect. Boom. Okay. And I think we're good. We got 6 and 4. 6 is going through. And perfect again. Nice. Okay. So we have a -1 this time and then a 10. So the -1 should get deleted. And that one gets deleted there, yep. Okay, I think we're good. Alright. Yeah, I think let's go. Alright, sweet. And only took me 400 ticks too. And only 26 chips, so Race can suck it. Yeah, that was good. That was good. All right, I guess should I end the video there and then just start a new one? So one video per problem. I think that might be better, especially once these problems get harder. So Also, it seems like my mic audio tends to degrade the longer that I'm streaming or recording, both. So hopefully that works. But yeah, if you're watching, thanks for watching. Appreciate it. I'll see you guys in the next video.